Okay, we are in chapter 7. We will be talking about systems of equations, and we're going to focus on section 7.1, systems of linear equations to variables. In this section, we will solve systems of equations by graphing, solve systems of equations by substitution, solve systems of equations by addition, identify inconsistent systems of equations containing two variables, and express the solution of systems of dependent equations containing two variables. So, a system of linear equations consists of two or more linear equations made up of two or more variables, such that all equations in the system are considered simultaneously. There are three types of systems of linear equations and two variables, and three types of solutions. So there's an independent system that has exactly one solution pair, the point where the two lines intersect. Okay, so that's what we're going to be looking for a lot of these. So where the two lines intersect, and in that case, there's only one solution. Then there's an inconsistent system that has no solution. Notice that the two lines are parallel and will never intersect. And then there's a dependent system that has infinitely many solutions and the lines are coincident. They are the same line, so every coordinate pair on the line is the solution to both equations. And here we have these illustrated. So this first one is the independent system with one solution. See, the solution is right here where the two lines intersect. Then we have the inconsistent system where there's no solution because the lines will never intersect because they're parallel. And then we have the dependent system where it's coinciding lines. So one line is on top of the other line, which means they cross at every single point, an infinite number of points. So we're going to first talk about solving equations and finding the solution and what that solution is. So the solution again is where the two lines intersect. It is also the ordered pair that makes each of the equations true. So if we were given a system of linear equations and an ordered pair, and asked to determine whether the ordered pair is a solution, we would need to substitute the ordered pair into each equation in the system and then determine whether true statements result from the substitution in both equations. If so, the ordered pair is a solution. So what I'm going to do is I want to see if the ordered pair 8, 5 is a solution to this system here. 5x minus 4y equals 20 and 2x plus 1 equals 3y. So I'm going to rewrite each of the equations. So I've got 5x minus 4y equals 20. And then I have this point x. I have the point 8, 5 where x is 8 and y is 5. So I'm going to substitute 8 in for x and 5 in for y. 5 times 8 is 40. Minus 4 times 5 is 20. 40 minus 20 is 20. 20 equals 20. That is a true statement. Okay, so it is the solution to this first equation, but what about the second equation? Is it the solution to it as well? So we have 2x plus 1 equals 3y, and instead of the x, I'm going to put in 8. Instead of the y, I'm going to put in 5. So 2 times 8 is 16, plus 1 equals 3 times 5 is 15. 16 plus 1 is 17. 17 does not equal 15. So is this a solution? It is not a solution to the system. It is a solution to the first equation, but it's not a solution to both. Okay, so the next one says solve the system of equations by graphing. So all you do to solve a system by graphing is literally graph each equation and see where they intersect. So I have two equations. The first one is 2x minus 5y equals negative 25, and the way you decide to graph, that's up to you. You can use a table of values, I like to put it in slope-intercept form. So I have negative 5y equals negative 2x minus 25, because you want y equals mx plus b. Then I would divide everything by negative 5, and I get the equation y equals positive 2/5 x plus 5. Then the other equation, I have negative 4x plus 5y equals 35. So I would add 4x to both sides, and I end up with 5y equals 4x plus 35. Divide everything by 5, and I get y equals 4/5 x plus 7. Now what I want you to remember is this is y equals mx plus b. So is this. That was the form we were putting it in. For the first one, the slope is positive 2/5 and the y-intercept is 5. For the second one, the slope is 4/5 and the y-intercept is 7. So I'm going to graph the first equation, and begin with b, begin at 5. So on the y-axis, I'm going to find 5. 1, 2, 3, 4, 5, and put a point. And then from there, I'm going to do the slope. The slope is 2/5, so I'm going to rise 2 and run 5. Now, I've 2 points. That's enough to draw the line, but because I want to see where they're intersecting, I want this this graph to go through all the points it's supposed to. So to find another point, I can go down 2 and left 5. So there is the first line. So I'm going to label it y equals 2/5 x plus 5. Okay, so now I'm going to graph the second equation. So that equation is y equals 4/5 x plus 7. So I'm going to find 7 on my y-axis. 1, 2, 3, 4, 5, 6, 7. And from here, I would go, do the slope, I would go up 4 and over 7. But I can't go up any further. I've run out of graph. So I can go the opposite direction. So instead of going up 4 and right 5, I can go down 4 and left 5. So let's see, down 1, 2, 3, 4, left 1, 2, 3, 4, 5. Oh, look at this. We can see where it crosses. Alright, so that was the equation y equals 4/5 x plus 7. And it looks like they cross here at negative 1, 2, 3, 4, 5, up 3. And then if you want to be certain, you can take each of these equations, the 2x minus 5y equals negative 25, and the negative 4x plus 5y equals 35, and substitute in your negative 5 and your 3, and see if you get these answers. So for the first one, 2 times negative 5 is negative 10, and negative 5 times 3 is negative 15. When you do negative 10 minus 15, you do get negative 25, so that works out. On the bottom, negative 4 times negative 5 is 20, plus 5 times 3 is 15. 20 plus 15 is 35, so it works out for both. That means that negative 5, 3 is a solution. Alright, before I go any further, I just want to show you that if you did Desmos, 2x minus 5y equals negative 25, you could type that in. 2x minus 5y equals negative 25. Okay, and you can see That's graphed. Then you can go, the second graph was negative 4x plus 5y equals 35. And you can see they cross there at negative 5 up 3. So this is a much quicker way to do it than trying to graph it by hand. All right. So let's see how we're doing on time. All right, so let's do talk about another way to solve systems of equations, and that is solving by what is called substitution. And it's exactly what it sounds like. We're going to be substituting as part of the process. So the first thing that you would do if you were given two equations and told to solve by substitution is you would solve one of the two equations for one of the variables in terms of the other. So looking down here, I have 4x plus 2y equals negative 10 and 3x plus 9y equals 0. You could either solve for this x or this y in the first equation, or this x or this y in the second equation. So you've got choices, and everybody could choose something different and still end up with the same answer. Once you do that, you substitute the expression for this variable into the second equation and then solve for the remaining variable. Once you get that, you substitute that solution into either of the original equations to find the value of the first variable. And if possible, write the solution as an ordered pair. And then check your solution in both equations. Okay, so let's write these down. So they were 4x plus 2y equals negative 10 and 3x plus 9y equals 0. So what you should do is pick a variable to solve for. So I'm going to choose this x. Okay. Now you can choose any of the variables you want to. I'm going to choose this x, and I get 3x plus 9y equals 0. Again, I'm solving for x, so I'm going to subtract 9y on both sides, and I get 3x equals negative 9y. Now again, keep in mind what we're doing. We're trying to solve for x, so now I'm going to divide both sides by 3. And I get x equals negative 3y. Now this is my revised equation. Okay, it is equivalent to the 3x plus 9y equals 0. I've just rearranged it and wrote it in terms of the x in terms of y. So now I'm going to take this equation and I'm going to sub it into the untouched equation for x. So I'm going to take 4x plus 2y equals negative 10, and I'm going to insert what x equals, and we said x equals negative 3y. So now you're going to simplify and solve. So we end up with negative 12y plus 2y equals negative 10. We add like terms, and we get negative 10y equals 10. I'm sorry, negative 10, and then divide both sides by negative 10, and we get y equals 1. Now, it would be nice if we were finished, but we're not finished, because now we need to substitute this into either one of these equations for y. And actually, a quicker way would be to sub it into that revised equation. Okay, so we can have x equals negative 3 times y, and we said that y was 1, so that means x equals negative 3. So it said write your answers in ordered pair. So your ordered pair solution is negative 3, comma 1, because it's x, comma y. And so then we can check our solution by taking the original equations and seeing if we get true statements. So for the first one, I have 4 times x, which is negative 3, plus 2 times y, which is 1. So 4 times negative 3 is negative 12. 2 times 1 is 2. Negative 12 plus 2 is negative 10. So that works. But does it work for the other equation, 3x plus 9y equals 0? So we have 3x plus 9y equals 0. And we're putting in negative 3 for x and 1 for y. So negative 3 times negative 3 is negative 9, plus 9 times 1 is 9. Negative 9 plus 9 is 0, so that works out too. So that means that we are correct and that negative 3, 1 is the solution. Okay. So your turn. You guys try this system, try to solve it, and then when you're finished, come back and we will check the solution. Okay, so if you look, this is already solved for x, so that's nice. They actually already did that first step for us. That's our revised equation, except it's not revised because we didn't have to revise it. It was already like that. We're going to take that, we're going to sub it in for x into that second equation. So 4 equals 3 times x minus 2y. And x is really y plus 3 because that's what x equals. X equals y plus 3. So now we're going to solve. So we have 4 equals distributive property, 3y plus 9 minus 2y. And then I have 3y minus 2y is 1y plus 9. Then subtract 9 on both sides and I get negative 5 equals y. Alright, so now I'm going to take this and I'm going to sub it back into that equation, x equals y plus 3. And we're saying that y is really negative 5. So x equals negative 5 plus 3, which is negative 2. So I think that our answer is negative 2 comma negative 5, but we do need to check and make sure. So let's check the first equation, x equals y plus 3, and we'll put in negative 2 equals negative 5 plus 3. That checks out. The second equation, 4 equals 3 times x minus 2 times y. And x, we said, was negative 2. Y is negative 5. We get 4 equals negative 6 plus 10. And that works out too. So we are correct. Our correct answer is negative 2, negative 5. All right. So we are going to stop the video here and then we will pick up in part 2 where we will talk about another method for solving systems.